Hi, everybody. It's Bruce Collins at Cambium Networks, and thank you for joining our webinar this morning, this afternoon, wherever you are in the world. Topic today is 220 megahertz spectrum options, and we have a couple of guest panelists with us today. We're going to go through some background on the 220 megahertz spectrum, and then we'll give you an update on some of the latest new capabilities and features with cnReach, not the least of which is the new 220 megahertz version. I am recording the session today, so you'll be able to go back to this and review it by going to our community forum and listening to the recording. And if you have any questions during the session, go ahead and put them in that chat window in the webinar interface, and we'll take those questions as they come, and there'll be plenty of time for questions at the end. Before we jump into it, maybe I'll ask each of our panelists to introduce themselves. I'm Bruce Collins. I'm the Director of Product Management at Cambium Networks, and I focus on our industrial portfolio, including our cnReach platform. John, you want to introduce yourself?
Yes, good morning. This is John Reardon. I'm the Managing Director of Choctaw Telecommunications. We own spectrum in the 217 to 220 megahertz band. Thanks for your time today.
And Bob?
Yes, good morning. This is Bob Finch. I run Select Spectrum. We're a brokerage for a variety of licenses around the country, and we actually have three different options in the 220 megahertz bands, three different types of services that I'll be talking about after John.
Okay, well, without further intro, I'm going to go ahead and jump into it. For those of you that are not familiar with Cambium Networks, I like to use this as a little bit of background. Cambium has been a player in industrial communications for quite some time, delivering solutions in the areas you see there on the left, so including SCADA process control and monitoring, video surveillance, replacing leased lines with private networks. So whether it's a wireline replacement or a 3G or 4G carrier or satellite comms, we can replace those with a private network and eliminate the operating expense. Automation, whether it's water treatment or electrical substations, and then remote office access with our Wi-Fi capabilities. So if you look at all of these industrial applications, we have a pretty broad portfolio to address those. The things that tie those all together are supporting wide geographic areas, lots of points of presence, and then delivering that data securely and reliably across the network. So to that end, we really focus on these verticals that you see there, the electric utilities, oil and gas, rail, transportation and operations, as well as the water and wastewater, stormwater management. We have a variety of products in that area covering a lot of different pieces of spectrum. So you'll see everything from licensed microwave with our PTP-820, backhaul products with the PTP-650. We move into aggregation, where you're delivering hundreds of megabits per second for video surveillance and access applications. Our CN Pilot product for Wi-Fi access. And then what we'll spend the bulk of the time today talking about is our cnReach platform, which is for SCADA process control and monitoring. Today, that product is available in 700 megahertz, which is a licensed band in the United States, 900 megahertz ISM and MAS bands, the 450 megahertz, which is available in most parts of the world as a licensed spectrum. And then we're going to spend a deep dive or go into a lot of detail today on the 220 megahertz spectrum in the United States. What we're really looking to do is align our products and portfolio to best support our customers' needs. And these are really the areas that we're trying to align to. The traditional reducing outages, reducing operating costs, aligning to the new IIoT initiatives that are brought to being with the new artificial intelligence and machine learning capabilities, and then reducing both security and risks due to cybersecurity and theft, but also safety of our employees and field craft as we introduce new capabilities out into the field. The users for cnReach are typically are all over the place, but basically in the digital oil field, we have applications in pipelines, digital signage control, floodwater and wastewater management, including monitoring for floods and flood stages, water treatment facilities I mentioned, and then on the rail side. So lots of different applications and lots of different users of the product. And one of the key aspects of the product is how do you get Spectrum to access these applications and be able to put in the communications infrastructure that can make these things go. So with that, as a brief introduction, I'm going to hand it over to John Reardon over at Choctaw Telecom, and he's going to give us a background or sort of his perspective of this 220 megahertz band. So with that, John, I'll just kick it over to you.
Thank you, Bruce. Good morning again, everybody. I appreciate the time today. Choctaw Telecommunications, as I mentioned, holds a spectrum in the 217 to 220 megahertz band. My own background is I've been involved in FCC-related businesses since the mid-90s. I've been a CEO and manager of companies in SCADA, telemetry areas, two-way radio, all focusing on oil and gas, utilities, railroad, and transportation, so what we call the critical infrastructure industries. Choctaw was formed a few years ago to buy some licenses out of bankruptcy, which were held by a company called Maritime Communications. If you can please go to the next slide, Bruce, it'll show a map of where we bought the licenses. So we recently received FCC approval for the purchase of the licenses, which are in the dark blue or purple shaded areas. This covers about 200 million people with 1 megahertz of spectrum. Again, it's a recent FCC development, so you may not have heard of our spectrum in the past, but it is now available and is being deployed by utilities, oil and gas, transportation, railroads, etc. In these areas. One thing to note is that in addition to the land-based areas that are covered here, we do cover all of the Gulf of Mexico. So if you have energy clients there, for example, it's a great solution. The spectrum propagates far. Some of the major cities that we covered, just sort of gee-whiz numbers, you can see New York, Chicago, San Francisco, Dallas, Houston, you know, and a lot of other major cities. So please go to the next slide. Thank you. So this is where we are in the spectrum band. As I mentioned, it's just below the 220 to 222 band. The AMTS stands for Automated Maritime Telecommunications Service. You can see we are in the yellow A block. It's a 500 kilohertz lower block paired with a 500 kilohertz upper block. So there's nice separation between the two. Please go to the next slide. Thank you. So you'll see here some of the license features of the band. As I mentioned, it is 1 megahertz in each market, licensed as paired blocks. The signal does propagate very far because of where it is in the 200 band. For example, we worked with the New Jersey Turnpike to deploy 22 sites in the state of New Jersey. They looked at 900 megahertz as an alternative, and the New Jersey Turnpike Authority came up with the decision that our spectrum would require 1/3 fewer sites, both to build and to operate, to cover the entire state of New Jersey. So, you know, if you have clients that are looking at projects that cover large areas like rails or pipelines, that signal propagation combined with the next bullet, which is the 1,000 watt power limit, you can broadcast at very high powers, you can go very far. So that's an advantage over this spectrum that has over 700 or 900 megahertz, for example, is just simply the fact that you'll need fewer sites, means less capex and less opex. So the licenses themselves, it used to be maritime spectrum, then the FCC auctioned it. They are 10-year auction licenses, and I think that was all that was on that last slide. Cambium seems to fit the need very well for narrowband machine-to-machine and SCADA type solutions. The cnReach product seems to be well received in the industry. We, as a company, we own licenses. We don't deploy systems. We rely upon companies like Cambium to take our spectrum and combine it with their solutions and offer that to their customers. So while we deal directly with your customer on the spectrum piece of it, we really follow your lead as far as getting in front of the customer, putting proposals together, working with your customers. So we both lease and sell spectrum, and some of the great uses for the spectrum include industrial controls, pipelines. We currently have, for example, Enbridge Pipeline Company, one of the largest pipelines in the U.S., uses our spectrum to control and monitor the pressure and other vital statistics along their pipeline. So it's good for meters, it's good for sensors in the field, whether it's wellhead monitoring, for example, Encana Oil and Gas in Texas and in Louisiana is a customer. It's also good for utilities, smart grid and other type solutions. We have a number of utility customers. We just closed a deal with Puget Sound Energy in Seattle. We work with Duquesne Light in Pittsburgh, Rappahannock Electric in Virginia, as well as Shenandoah Valley Electric, Dixie Electric in the New Orleans area down in Baton Rouge. So there are a number of utility clients that find our spectrum to be very useful for narrowband data solutions, such as those offered by the cnReach product. As I mentioned, we're in the oil and gas market. Transportation, we are a very active player, not just with the New Jersey Turnpike and highway sensors and what we might call intelligent transportation systems, but also in the railroad market. Our current clients include Positive Train Control, a group called PTC 220, which purchased some spectrum from us in the Connecticut area and the New York area recently, as well as Amtrak, Southern California Regional Rail in Los Angeles, and other rails. And what they do is they use the solution for train control, but it's also very useful for other industrial IoT type solutions for rails. So this last bullet mentions Choctaw's clients and who they include. As I mentioned, it is really in that sort of critical infrastructure industry that we seem to have the most success. Please go to the next slide. So some other sample applications for the spectrum use. Anywhere you can think that you might need a SCADA type solution, agriculture, monitoring crop solutions and watering and those sorts of irrigation issues, for example. Smart cities. Cities spend, I think the largest part of a city's budget seems to be highway lighting and road lighting. And so to the extent that cities can save by having sensors on their streetlights, parking meters, other types of smart city solutions, our spectrum works very well. Smart cars, intelligent highways, and collision avoidance. We mentioned Positive Train Control. One area that we're not involved in enough, but we'd like to be, is drone communications. Drones fly up and down pipelines and railroads and trackage, looking for, and utility lines, looking for arcing in the case of utilities, or cracks in the track in the case of railroads. And we think there would be a good application for us to work with you on drone communications if you have any clients interested in that. Vehicle tracking is kind of an obvious one because we do go so far. We are close to low jack in the band. Environmental monitoring is another solution that seems to work well. Because our spectrum is narrow band and it travels far outdoors, it does seem to be good for this type of, whether it's seismic monitor devices, used by folks who would do geological surveying, for example, for fracking, or other types of environmental monitoring solutions. We think we'll see more and more of those in the future. Please go to the next page. Thank you. And so that's pretty much a wrap on what I had to say. I know we'll have some, we'll be doing some questions and answers, but I do appreciate your time today. We are actively in the market selling and leasing the spectrum. We can disaggregate channels. So if you don't want to buy all of the spectrum in a particular area, your client can acquire a slice of it. Similarly, if they want to acquire one area but not all of the spectrum licensed area, we partition as well. Our leases are normally 10-year leases, and as I mentioned, we are very active in the marketplace, working alongside others who have spectrum in the same and similar bands. And I think you'll hear about that next from Mr. Finch. So thanks for your time this morning, and I'll hand it over to you, Bob.
Great, thanks, John, and thanks for a really good summary of the AMTS spectrum. So the AMTS is one of 3 different sets of frequencies that are available in the band. I have only one very small point that I would perhaps dispute or take a different perspective. I view this as AMTS, and for that matter, also the 218, 219 service, as what I call wideband spectrum. It's not broadband. It's not the kind of spectrum that you have to compete with Verizon or AT&T for, but it is wider than what we have conventionally called narrowband spectrum. And so we hope that in serving all of the types of needs that John described, and I think Bruce also gave a preview of, there's additional capacity in these first 2 bands, especially to provide substantially more bandwidth than has previously been available. And the 220, I think, is a band that is really coming open. The Cambium product is a sign of that. The transactions John described and I'll describe are a sign of that. This is a band that was kind of in the backwaters. There were some issues with the FCC and the former owners. All of that is behind us now, and I think it's a great opportunity for companies to acquire some great licenses. So I'll talk, and we can skip forward to the next slide if you like, Bruce. This is a picture of the same band plan. I'll talk about 3 different types of services. So the AMTS service, John has just done a great job of describing. Our client holds different licenses in different places, both A and B block, and covering really almost the entire country on these frequencies. And I'll show you a map of that in a moment. We have additional different clients that hold 218, 219 megahertz service. This was formerly called IVDS service. There are 2 500 kilohertz licenses in each area, and typically these are in mostly in major metropolitan areas. Some are in some secondary metro areas, and provide additional capacity compared to AMTS in those areas. Also have slightly different seller characteristics, but very similar propagation. And then finally, there's the 220 megahertz service. This shows as a single block. There's actually broken up into a variety of different channel plans. Some of them are quite narrow, others quite wide, and we have fewer of those and narrower coverage, but they could fit in particular areas. So why don't we move forward to the AMTS map? I said that this covers the majority of the U.S. So you see that in Vermont and in portions of the Rockies, we've run out. The darker blue, by the way, here are places where we have up to 2,000 kilohertz of licenses available. So typically both A and B block in those areas. The kind of greenish color is typically up to 1,000 kilohertz of spectrum available. And then the lesser amounts are in the other colors. So generally available most everywhere. Obviously, Los Angeles, San Diego are missing. So that's, I'll come back to that later, but that's a significant populous area. But all the other major cities around the country are available in these frequencies. And you see counties are actually shown on this map. The licenses are much broader areas, but the license holder has agreed to divide them up as small as the number of counties that you want to serve. And then also, as John described earlier, Susan Euchre is the receiver managing these assets. She's able to allocate a portion of the licenses. So if you don't want the full 1,000 kilohertz or whatever is available in a given area, you can make an offer for a smaller portion. So this is one of the reasons.
That was actually one of the questions that we had just come in line. So since you just mentioned it, you talk about 2 1 megahertz blocks. What is the granularity that you would license a subset of that 2 megahertz total?
We've done transactions as low as 100 kilohertz so far that I'm aware of. I'm not aware of anything narrower. I think in part it's a function. There are some transaction costs in this since it has to go through the receivership. So we want to see an overall transaction that's, I don't know, $100,000 or something like that, kind of on the low end. If you're talking about 100 kilohertz in a rural area, you can buy quite a few counties for that. If you're talking about New York City, it rapidly escalates above that, and I'll talk about pricing here later. But so typically in the AMTS band, think about 100 kilohertz as kind of being a reasonable minimum, and we think that people would be more inclined to go for narrowband channels if they wanted less than that. So let's go ahead and step to the next slide. This talks about the developments on the spectrum we're representing. Almost 2 years ago, Susan Euchre was appointed receiver. This is a case that was a number of spectrum holding companies that are being monitored in the California Alameda County Court. We've been marketing the spectrum since shortly after that, and we closed 4 transactions in 2016 and so far this year. And then the additional companies there listed they have transactions that are pending before the FCC, which we expect to close soon. Some of those have actually been consented to, but haven't closed yet. So, you know, this is an example of the kind of progress we're seeing in this band, and we're glad to see Cambium now manufacturing a product that fits in the band as well. So maybe we can flip forward to the next slide. In terms of deployments, so this is part 80 service rules. John talked about the maximum downlink power of 1,000 watts, 50 watts in the uplink, you know, tremendously strong compared to what we're used to in other bands. We guess, you know, conservatively with, if you have just 1,000 kilohertz, you should be able to handle 1 megabits per second per site. My guess is Cambium will tell you that it's higher than that in many cases. And here are some of the companies that have deployed this across rail. Transco and Eversource are both utilities, so is Pepco, and then in the oil and gas. So very similar to the types of customers that John had described. So now I'm going to switch to the next block of licenses. This is much more limited geographically. But if you look at the locations, you know, Miami, Chicago, St. Louis, Dallas, Houston, these are in cities, Denver, and some smaller cities that are very important to certain customers. And importantly, I don't know if you noticed, but on the AMTS, we had a hole in the map covering Los Angeles, so we do not hold, the receiver does not hold a license there. However, in this case, Los Angeles is available in the 218, 219 megahertz block. So these licenses are typically 500 kilohertz. In some cases, we actually have both. Los Angeles is an example of that. So you could buy a full 1,000 kilohertz block of that license. So it complements, particularly in the LA case, the holdings that we have, or offers a potential buyer who's looking to get into the wide band the opportunity to get both AMTS and 218, 219 in particular geographies. So the description of the services on the next slide. This is part 95 service. It has lower power limits than the AMTS, but since it sits in the middle between the AMTS, the FCC has approved very high power operations. There's no other interferers or other users in these bands. It typically uses the same equipment, so the Cambium equipment will work in these frequencies as well. So normally, if you're doing two-way operations, it would be what I call time division duplex. I guess half duplex is what some people would call that, but transmission alternatively in both directions. And you saw the markets that have been that we're offering. Others have been sold. So this is being used by the subway system in New York and in Philadelphia, for example, to manage their train systems. So similar, I think it is actually the same positive train control application. And then the last service that I'd like to describe is shown on the next page. More limited geographically so far, although these are multiple different clients. You see Houston and New York as being significant markets, Roanoke, Virginia as well, Southwest Virginia. So these are the narrower channel licenses. They could be more economical because of that narrow channel type arrangement. And we are, continuing to develop this market. We expect to get both sales and additional licenses in these frequencies as well. Some of these are as narrow as 5 kilohertz. Why don't you flip to the next page there, Bruce? Thank you. And at 50 kilohertz is commonly available in this band as well. And these are Part 90 service rules. So in that block between 217 and 222 altogether, you have different rules, but in general, great propagation, no significant interference issues, and good availability of equipment, including the Cambium. So this, what I always get asked about is pricing, and the pricing varies some between these three bands. I'm sorry. None of them have the firm, asking price that was established by Access Spectrum initially, and then my client Beach Point Capital in the upper 700 megahertz A block. But I think it's a comparable block. The public price of that, which I think has helped the market kind of figure out, okay, how much would it cost me to get a license? It's helped with budgeting and things like that. Is the 75 cents per megahertz block. So our view is, at least Select Spectrum's view is, that since propagation at 217 to 220 is longer, buyers, if they're considering making an offer, should at least from a budgetary perspective, think above 75 cents per megahertz pop. And on the next page, I'll describe how that would apply in a particular case. So I was surprised in the license covering Fort Wayne, Indiana, and the surrounding suburbs and exurbs, the total population is 500,000, and I think that's a useful kind of a number to look at. So 500,000 pops, if you were to acquire 1 full megahertz, 1,000 kilohertz, that would be 500,000 megahertz pops. At 75 cents, that would be $375,000 at $1 per megahertz pop. So I'm trying to kind of show the range there. It would be 500,000. If you were to say, no, I don't need that much, and I think John and I have both said we're offering, division of the licenses where the buyer would like to do that, the pricing would be essentially half those numbers, since you're dealing with half as many 250,000 megahertz pops. So the range 187 to 250,000. And then we did the 100 kilohertz example. So here's a case where, at least for AMTS, we would be reluctant to do a transaction as low as $37,000 or $50,000. So we've been encouraged by either more geography or more kilohertz. And I'd say that this is an example. It's not specific to any band. In general, my 218, 219 license holders would like to sell their whole license, and they might consider a lease as well. They're not so interested in this dividing according to by the kilohertz or by the county, but they may have some more flexibility in pricing because you're buying the whole thing, and they may be open to a lease. The MTS, we don't expect to do leases in that band, other than maybe a short term or something like that. The long-term objective is to sell those licenses. And the 220 really varies by the client. So I hope that's helpful just in terms of describing the overall pricing to give you a guideline. I guess a comment I'd say is both John and I have described these licenses. If you have questions about who's got what where, certainly welcome to call us directly. Jonathan Shawhart and Kent Brown of Cambium can also be an interface point where if you're not sure who's got what where, you could come through them and they'll be aware of what our inventories are as a suggestion. And I very much appreciate your time, and we'll turn the mic back over to Bruce.
Okay, thanks, Bob. Nice discussion there. There are a number of questions that have come in, so let me hit some of those now. One of them is, I think maybe both of you could answer this one. What is the time from the time somebody expresses interest in a piece of spectrum till it's fully approved and ready to put radios on towers? What's that time window look like for these different bands?
John, why don't you tackle that first?
Sure, thanks. I appreciate it. So as I mentioned, the FCC just recently approved a transaction involving Puget Sound Energy and Choctaw Telecom. They also have just in the past week approved Duquesne Light in Pittsburgh transaction. So we feel that the FCC is moving faster than they have in the past. The new administration certainly has something to do with that, less regulatory approach and a more transaction-based sort of approach overall at the FCC. So the tone really is set at the top, you know, of the commission as far as processing and getting applications filed. We also feel pretty strongly that the FCC people at the Wireless Bureau are aware of how long it's taken in the past. Some of the roadblocks have been cleared away. Certainly in our situation, since we have acquired spectrum that was formerly in bankruptcy held by another party, we are now in a position where we are free and clear as the licensee to sell and lease and file these applications. Our normal process is a very short asset purchase agreement, and by short I mean 6 or 7 pages with an attachment. So we don't have a lot of paperwork required, not a lot of bureaucracy here. We work with our FCC attorneys to file the relevant FCC filings. So we can work within a week or two of first conversations to have a contract and an application on file. We do not need any court approval. Some others, I think one of Bob's client might need court approval. We do not need court approval for any type of filing at the FCC. So to answer the question, I would guess that the normal sort of you know, scenario going forward to enter into a purchase agreement, we should be able to get an assignment application filed within 2 to 3 weeks of you know, first talking to people, certainly within a week of signing a contract. If it's a lease application, we file that pretty much right away, and then the operator, the lessee, can begin to operate 21 days later. And so what we've often done in the past is enter a purchase agreement, but at the same time enter a lease agreement that allows the company to begin to operate 3 weeks later, and then the lease just terminates when the assignment application is granted and when they own the license. So a long way of saying we can get an application to assign the spectrum on file very quickly. Hopefully the FCC would act on that within 60 to 90 days, and the matter could be closed within about 120 days. We'll see if that's the case going forward, but we believe that we're very optimistic that that should be the case. Bob, I'll hand it over to you. Thank you.
So the answer is I have some clients who I think can do it quicker than that, just because you know, they're small organizations, and we've seen overnight assignments by the FCC in some of these bands. And so then you'd normally wait something like 60 days from the time of filing to close. So less than 90 days overall. John is absolutely right with the receiver in the AMTS cases. In addition to the FCC approval, there's court approval required in California. So you probably add another 60 days to that process, and you can be out into the more than 120 days to close, maybe at the outside 6 months from the time you know, enter serious discussions. So it's really it's a case of varying time frame depending on what you're buying, who the seller is, and to a large extent who the buyer is. You know, if these go to a utility, for example, they're not always the fastest in terms of negotiating the contracts. The contracts are not terribly complex in and of themselves. So great variability. But what I'd say is in the past in this band, there was some uncertainty, and I think that's gone. So you know you're going to get it. It's a question of how long is it going to take, and you know, hopefully we've described the range.
Okay, thanks both of you. There's another question. This one I think particularly for John. This drawing of the AMTS spectrum, the map I'm showing on the screen now, it has a blue line through Wisconsin and Illinois. Is there some significance to that line?
Yes, great question. So the blue line denotes the FCC license boundaries. And so if you look to the eastern part of Wisconsin, that is in the Great Lakes license area, which we own. The western part of Wisconsin falls into the Mississippi River license area, which we own. And so we own all of the state of Wisconsin, but there would be basically, you know, that's the FCC's sort of artificial line for dividing the Great Lakes from the Mississippi River. And then if you look down in the Virginia area, you can see the Mid-Atlantic license is sort of North Carolina, Virginia, Maryland, Delaware, portions of Pennsylvania. And then similarly out on the West Coast, you can see the Southern Pacific license is the you know, area of California that's below that light blue line, and then the Northern Pacific license is, you know, part of that part above up in Oregon. So that's the reason for those blue lines. But if you take away those blue lines, you know, we basically own all of that purple space.
Okay, great. And then I think a related question is, somewhat related, is when you have adjacent territories, what is the FCC rules in these bands about adjacent geographies? The specific question they were asking was around antennas and being able to have basically adjacent license holders, one county over from the next.
Yeah, so if it's, and I'll let Bob answer this after me, but the AMTS rules allow for a 20 dBu interference contour. And so if you look in the New Jersey, New York area, for example, where we have some incumbent licenses, we operate and are protected at a 20 dBu interference contour. The co-channel license holder, their 38 dBu service contour cannot come into the 20 dBu interference contour. So there are very specific FCC rules that protect operators at the boundaries, and that's pretty typically done, because as we know in the real world, spectrum doesn't stop at a you know, geopolitical boundary. It keeps going. So, but it's been pretty clearly marked out by the FCC what the obligations are on a co-channel basis. I'm not sure if they were asking about adjacent channel interference, which is, you know, the band up above or the band below, but there are some emission mask, you know, requirements at the edges that protect each other. So.
Okay.
Yeah, I think John's provided a good overall description. I don't honestly know the specs band by band because they can vary from one license to the next. So it's definitely worthwhile, particularly in these bands that propagate so well, to, you know, consider those engineering issues as you look at a design, and I think Cambium could help with that. The thing I will say is that if you have a different agreement with your neighbor to, for example, allow a higher power level, or lower for that matter, you know, that's also allowed, right? The FCC sets a standard rule, which is basically if you don't agree with your neighbor, this is what you have to live up to. But we've seen, at least in other bands, you know, parties say, well, we can coordinate timing, or we can have a frequency plan, or there's ways that we can adjust at our borders that are even more optimal than what the FCC allows.
That's right. And, you know, Bob, you also remind me of an important issue probably to talk about with our friends on the phone, is in the AMTS band, you are able to channelize the band. So both for our spectrum and for the spectrum Bob represents it from the receiver, you know, you can have a 12.5 kilohertz channel. You can have a 25 kilohertz wide channel. It can be 50. You can use all of the 500 kilohertz block as a channel. So there is flexibility as you design and work with your clients. And, you know, some clients might want a faster speed, so they might want to put the 25 kilohertz product there rather than 12.5 or 6.25 or whatever. So there is flexibility in the channelization, and I should have mentioned that earlier.
Next question on here is, I think, Bob, in your discussion on pricing, when you refer to POPs, what is the metric that's used to calculate the POPs in the different regions?
So the population is the Census Bureau population within the relevant counties, or, you know, if we ever end up doing something different than a county, we would look at ways of breaking it down differently. And we use the most recent pop count, which is 2016 population estimates from the Census Department. So that's, and it's the number of people who reside in those counties. It's the permanent population of the counties.
All right. Another question came up about Hawaii doesn't appear on the map. Is there any, you guys have any information about Hawaii?
I think we have the AMTS in Alaska and Hawaii as well. We don't have any of the 218 or 220, but I believe we have at least 1,000 kilohertz. We can check that and get an answer before the end of the call.
All right. Okay, well, I'm going to continue on. These are great questions. I appreciate everybody putting them into the webinar interface. So if you have something you're thinking about, we'll have plenty of time here at the end to take additional questions. I'm going to summarize a little bit about cnReach, which is our narrowband platform for SCADA process control applications. The key aspects of cnReach are really around deployment flexibility. So with that radio that you can see there on the right-hand side of the screen is a device that can be deployed as a point-to-point solution, a point-to-multipoint, meaning that same radio could be an access point or an endpoint. It can also serve as a store and forward relay and a what we call a back-to-back relay, where I have dual radios in that module and can talk simultaneously eastbound and westbound and do relay configurations for extremely remote areas. The product's available in the 700 megahertz license band, which Bob's also representing a large portion of that spectrum in the US. It's available in 900 megahertz, both MAS licensed and ISM unlicensed. The 400 megahertz bands around the world, and then we're just now launching, and this is actually available today with our 220 megahertz solution, which I'll talk about in a little bit more detail. Reliability is important. We test every one of these radios from neg 40C up to plus 85C in the factory. That's both a functional test and a burn-in test. So we make sure that these are operating and communicating at the widest temperature range. Low power consumption. We have recently introduced some low power modes in this radio that can bring the power consumption in idle mode to less than 60 milliamps at 12. So if you're looking to do a battery panel, perhaps in the oil and gas industry or digital signage area, certainly that the power profile fits that quite nicely. Scalability, we can synchronize these radios. They have adaptive modulation. And then there's a number of features to really optimize for licensed spectrum use, being ability to filter out unwanted broadcast traffic and unicast traffic using whitelists and filters, as well as layer 3 static routing. As with all Cambium products, we have security built in, so encrypted 128, 256-bit AES. And then we also offer Link Planner, which is our free planning tool that you can download from our cambiumnetworks.com website, and also CN Maestro, which is our cloud-based or on-premises-based network management system that can be used for monitoring the system, doing security parameter updates from a central location, and then also doing visual troubleshooting of where the devices are and any issues that might be happening with those devices. A couple of nice fixtures. Here's an example of a deployment in a very remote area. This is up in northwest Canada, just to the side of the border of Alaska. So it gives you a list of the remote areas. This is actually a radio over IP application showing the use of voice communication over a narrowband channel, delivering voice into a very distant and remote area. We also have been doing a number of field tests at 220 megahertz. This is a good example of the propagation that you can achieve with 220 megahertz. This is at our office or facility headquarters in Rolling Meadows, Illinois, just outside of Chicago. You can see our office building there in the upper left. And then down in the lower right, you'll see the picture of our test vehicle and the testing that we've done in this very dense foliage area. Some of the results, and we used everything from 200 kilohertz channels down to 12.5 kilohertz channels, and showed the propagations through that dense foliage going about 1.6 miles, and that was still achieving the full modulation by connecting through that with just a Yagi antenna at both ends. So I think John might have mentioned that you can do different channelization in the AMTS band. We do support up to 200 kilohertz channels in that band with the cnReach radio. So here's a couple of the key specs. Certainly you can get more detail on the specification sheet or by contacting us over at the website, or dropping me a note. Also, Kent Brown and Jonathan Shawhart are available for more deep dive discussions on this. The product does support all the bands that John and Bob have been talking about today, 217 to 222 megahertz. We have FCC certifications and grants for both Part 90 and Part 80, so that and you can see the transmit powers that are available there in various channel sizes from 12.5 up to 50 kilohertz, and then in that AMTS band we can add 100 and 200 kilohertz. So you can start to see the capacity start to build up there. Range is up to 70 miles. Certainly the propagation goes a long way with this, and certainly with some different antenna options, you can get a lot of coverage area with a small number of access points. Here's a visual of those different deployment topologies showing point-to-point, point-to-multi-point, the different relay mode operations. But effectively with that same hardware module or radio device, you can configure a lot of different approaches or different layouts. So whether you're doing a pipeline application, traditional SCADA process control, where I'm looking at a lot of point to multi-point, or that example I showed before, which is radio over IP. I just need to do a point-to-point link and deliver packets over the air as fast as I can. Another capability of the product is it supports built-in general purpose IO. So some customers have deployed the product with directly connecting sensors and dry contact switches and controlling devices directly off the radio. So in some cases where I have simple needs or some small application for that digital IO or analog IO, I can eliminate an external PLC or RTU and go directly to using that general purpose IO that's built in. We did just release system release 0110. That firmware is available on our website. It's fully compatible and working with the 220 megahertz product. You can go to support.cambiumnetworks.com/downloads, and you can get access to not only the application software and the firmware for the radios, but also the latest version of Link Planner and the latest version of CN Maestro. There's some release notes and more information about that release in our updated user guide that's also available there. I'd like to show a little snapshot of CN Maestro. This is the dashboard view for a cnReach radio. You can see in the middle, lower middle there, a view of the cnReach radio. It automatically identifies the topology of the radios. You can see that I'm talking to an endpoint, or I'm focusing on an endpoint, and it's being served by a dual radio with an access point. And you can then further see information about how the radio is configured, what's the health of the link, what's the consumption and capacity of that link, and I can look at that metric over a long period of time. Along with these radios, we offer a variety of antenna options. So we have Yagi antennas, we have an Omni antenna. All of these are supported in Link Planner. So if you want to do what-if scenarios on if I change the gain of the antenna, or if I change the height of the antenna, you can see what the impact of both the throughput and the availability of that link. So that's one of the benefits of selecting one of these antennas. We also have a set of turnkey installation kits that can be ordered alongside these antennas. and that includes basically all the pieces that you need to implement a radio at a cabinet site or at a location where you're adding wireless connectivity. So it includes grounding kits, weatherproofing, zip ties, all the things you need to do to complete a professional installation, as well as RF surge suppressors and all the jumper cables needed to get from the antenna at the top of the tower down to the radio inside the cabinet. I'm going to switch back here and see if there's any questions that have come in since then.
Bruce, I can jump in if it's okay about
Sure,
Hawaii and Alaska.
Okay.
So yes, it turns out that we have a very good portfolio of spectrum in Alaska, Hawaii, Puerto Rico, Guam, and the Virgin Islands. We have 2,000 kilohertz of AMTS there. So if anyone is looking at an extra 50-state strategy or an extra 48-state strategy, that's a good opportunity. Oh, one other thing I want to mention is all of our licenses are listed on our website, at least in the 220 band, all of these frequent licenses. So that's selectspectrum.com, and there's in the upper right, there's something called the Spectrum Selector. So you can look at different frequencies and different states and find out what's available in your area.
Okay, Bob, there's a question for you on the 218 to 219 megahertz spectrum. Are you aware of any electric utility companies using that spectrum? Again, that's the 218 to 219.
I am not so far. That tends to cover metro areas, and so most electric utilities that cover metro areas also cover broader areas. So we've seen more interest from them in the AMTS. But we're trying. We certainly have made them aware that this is here, and there are places where it could be a good match.
Okay, there's a question about is the Cambium 220 megahertz cnReach product Part 95 certified? As of today, we have Part 80 and Part 90 certified. We are investigating Part 95, but that FCC grant is not complete yet, but something that we're looking into. Then there's a question about what is the maximum channel size on the cnReach product. So that today that channel size is 200 kilohertz is the maximum. So you can do anything from, well, not anything, but a certain selection from 12.5, 25, 50, 100, and 200 kilohertz. And then latency, what are the latency expectations? Latency on this can be on the order of below 100 milliseconds. Of course, it depends on the payload size of that packet. When you talk about narrowband 12.5 kilohertz channels, as you adjust the payload transfer time starts to have a larger impact on the latency. So the latency value will change a bit with payload, but you can kind of look at that 100 millisecond range as the target. While I'm waiting to see if there's any more questions coming in, we'll give a couple of advertisements here. We do ask that you take a look at our Facebook and Twitter feed, especially LinkedIn is a good place to get a hold of us. But probably the best place to get some of these discussions or keep them going after the webinar is complete is go to community.cambiumnetworks.com. We have discussion groups and forums on there for cnReach and for various industry verticals. This is also where you'll find the recording of this webinar, so you can go and review it or share it with someone else who you want to share the information with. We also have many of our engineers, product line managers, support team are active on this forum. So if there's a question that you don't find the answer to in the user guide, or it's one of these really obscure what if type of questions, that's a great place to go, and you'll often get a question answered within the same business day.
Bruce, I do have a correction. Thankfully, one of my colleagues who understands this stuff better than I do was listening in. We believe that Pepco Holdings, which is a division of Exelon, is using the 218, 219 megahertz.
Okay. While I take a couple more questions here, you can see the contact information for both John Reardon and Bob Finch at their respective email addresses and phone numbers. And then you can also contact me at Cambium Networks. The question came in about, was this webinar available on YouTube? It's available on our community.cambiumnetworks.com, so you can get access to it there. I believe they might cross-post this to our YouTube channel as well, but the best place to go is right to the source at the community forum. What is the input on a cnReach point-to-point and point-to-multi-point link configuration? Let me jump back to that slide because capacity will vary depending on a number of variables, not the least of which is the channel bandwidth. So you can see in a 25 kilohertz channel, you'll see up to 50 kilobits per second, and in a 200 kilohertz channel, up to 690 kilobits per second. These are quoted as real usable data, so real UDP traffic. The other variations to consider are the radio does do adaptive modulation. So if there is some interference or propagation that causes the link budget to force the radio into a lower modulation, that will happen automatically, and you'll see that speed vary with the conditions of the link based on the hitless adaptive modulation algorithm. So idea in the user guide, we list every modulation, every channel size, and even depending on the packet size of the average packet size of the data, you can look up what the real measured throughput is on a given software release. So we do track that and show that very explicitly in the user guide. And then the other thing I'd say is go ahead and plug your link into Link Planner, and it will give you a real good indication of what to expect on a particular link, given the actual terrain that you're trying to close the link on. Okay, we are arriving just at the top of the hour. I appreciate all the questions we had. It's been a very interesting discussion and very helpful for having both Bob and John give their perspective. I want to thank them for their time. So thanks, Bob. Thanks, John, for participating in the webinar. And
thank you.
Have a good day, Bob.
And,
take care, Bruce.
Okay, thanks, everybody. We're going to call it a wrap and talk to you next time on the next webinar.